Alright, we got BCA-101. This was 1416. I believe day 7 of the course. We talked about reading materials, and when you read those, read it for content, not just browse through it like you start a new unit and so forth. I answer a lot of questions that are in the materials, and you could have read them and just forgotten or missed it, but you need to be detailed when you read the materials and read it all. Some people, I still have an issue, and we've talked about this before, all they want to do is the task. That's all they want to do. They just want to get the task done. Okay. We talked about the outline, and you need to be referencing the information that you get in the outline. You need to give the source. And there's still a few students, a little bit of question, but we talked about that. And in the unit completion, it reviews how to do that peer review of the outline. We got started on word processing. Talk a little more about that in a little bit. And then we took the first skills-based. Interesting. Okay. As soon as there is more points, all of a sudden the level of concern went up. When the level of concern should go up when you do the work, because that's when you learn. Anyway, talk more about that later on. We talked about computing history, knowing a little bit about the past. We're using technology a lot now. Why? Why do we use technology? A computer can't do what we can do. Our brains are way sophisticated. Okay? That's supposed to be a brain. Okay? Way sophisticated. No machine can match human intelligence. But what a machine can do, it can work extremely fast. Okay, we talked about milliseconds, picoseconds, and so forth. It can perform instructions at an unbelievable speed. And nowadays we can move information from one location in a network to another because we have such high bandwidths. Bits per second. So internally, the computer is extremely fast to do this processing. Internally, a little bit slower getting information off of hard drive, but we talk about megahertz, millions of cycles, or gigahertz, billions of cycles. A billion, so a gigahertz machine might be, 2.4 gigahertz. So it does 2.4 billion clock cycles a second. So it can do 2 billion things every second. 1,001, 1,002. Okay, we're up to 4 billion already, or 5 billion. Okay. The next thing, software nowadays, if you get the algorithm right and you put in the data correctly, computers are very accurate. They'll give you the right answer over and over and over, and they can do it with large amounts. Kilobyte, megabyte, gigabyte. Okay, when we talk about bytes, typically we're talking about an amount of data. When we talk about bits per second, we're talking about the data that can move through a medium, or yeah, pretty much through a medium in a certain amount of time. So how many bits can move through there in a certain amount of time? How many bytes? We're talking about quantity. So a good comparison is bandwidth is usually measured for your access to an ISP, but for your LTE, your 3G, 4G, when you're connecting to a tower, they kind of manage the speed. They manage the speed. You don't have any control over that. But in order to keep the volume down on their lines, they make you pay for how many bytes you literally move. Okay? Remember, 8 bits, approximately 8 bits give us a byte. So memory is measured in how many bytes. Your storage is measured in how many bytes. Finally, computers are extremely reliable. We trust them to do lots of things, more things than we can even imagine. From managing the temperature in your house, to cooking your food in a microwave, to autonomous cars, to flying airplanes, to even in surgery now, there are lots of technology that assists the doctor in doing surgery. Computers have become very reliable. So if you think about it, if you have an employee that works at a high rate of speed, doesn't make mistakes, and can do a lot of work, it can do a lot of work at a high speed, that'd be great. But if they were unreliable, then if they get sick, or they get sore back all the time, they don't show up for work or whatever, these become mute if you can't trust. But nowadays, this has gone up tremendously in technology. Now we need not to confuse, the World Wide Web uses the Internet. It was a great idea to where we can create websites. Okay, we can create a website in the cloud, stored on some server, and then using this technology, a piece of software, at another location, connected in the Internet. So in here you can use some type of device that has something that allows you to browse. And what we use is we use this language. We can take and create the information here using HTML. We can take the HTML and get it to our browser, then our browser can interpret it and create a nice looking page, view that website. How we get the information through, you send a URL, ends up at the right location, the HTML comes back to your browser makes it look nice. Okay, there's a protocol that does that, Hypertext Transfer Protocol and Hypertext Transfer Protocol Secured. If we're using this one, later on you'll learn that's port 80, you can move this information freely, but it's not encrypted. If we use HTTPS 443, I believe is the port, I have to look that up. Now the information is encrypted and then sent through the network. Decrypted, encrypted, sent through the network. So make sure you have an S if you're sending anything important across the network, like the password to your bank account or any passwords or so forth. Alright. Word processing. Get it to say what we want it to say and get it to look the way we want it to look. We can sell a point or not sell a point. We can make something flow easily as somebody reads it or make it difficult for them to read it. We talked about the sweet point. There's a word for that. And then people do a lazy Z. I gave the simple example somebody might have. In fact, this was a real example. A bottle of some kind of liquor, poured it into a shot glass, and here was the brand name. They had all kinds of text here, but did anybody ever read it? No, sweet spot. You go to there. You should have done a lazy Z. But instead of a lazy Z, we redirected your eyes to shot glass, product name. You exit the advertisement and go on to the next page of your magazine, your browser, whatever you're looking at. So we're going to do word processing about a week and a half. And we're going to talk about emphasize. Editing, getting it to say what you want to say, and then getting how it looked to make it easy to read, or in some cases, some people purposely make it hard to read. An example of the fine print in a document. Or I also gave the example, credit card information, written at 11th grade level. There's a lot of people in the United States that can't read at 11th grade level, but have a credit card. So do they really understand all that information about when the interest starts or how much the interest is? No, they don't understand that. They don't understand that because they don't read at 11th grade level, but they still have a credit card. All right. So again, to emphasize, in every unit you should strive to work on the outline ahead of when we discuss it in class, and there is that general timeline at the end of the syllabus that gives you an overall view. It actually gives you which sections of the outline you should be doing, what days. It's actually that specific. Okay, going back to the syllabus, you know, specific things like there is no late work unless you discuss that with me, and so forth. And then you work through the assignment on word processing, and I gave you a couple solutions so you can see if you're doing it right. And we do the project, and then I'll give you a solution to that after you turn it in, and then we take a skills-based assessment in class on the project where you get to apply your knowledge. And while we're doing all this, you're always keeping up with the outline. 2 things. That's it for today.